Hello everyone, welcome to the tutorial number 3 for IIT-JAM in chemistry. And today in the second lecture of basic mathematical concept under physical chemistry, the subtopics which are going to be discussed are maxima and minima, integrals and ordinary differential equation. So let's start from maxima and minima. Here is a graphical presentation of some function of x against x. Here the value of fx is changing with respect to the value of x. So x is the independent variable, whereas fx is the dependent variables. So starting from this point, the value of fx is decreasing. After moving forward to some extent, it has stopped decreasing and then again started increasing, and here at this point it has stopped increasing and again this then started decreasing. This way it is moving like a sinusoidal curve this way. So here this point and this point are the minima. Minima is actually the plural of minimum, and these 2 points are maxima. Maxima is the plural of the term maximum. So the highest value of a function fx within a certain range of the variable x is the maximum. Similarly, the lowest value of a function fx within a certain range of the variable x is the minimum. When a function increases, then at some finite point it may stop increasing, so that its differentiation, that means f dash x, that means dy dx is equal to 0 if y equals to fx. Similarly, at the time of decreasing, it may also stop decreasing at some finite point. Here also f dash x, that means dy dx equals to 0 if y equals to fx. Therefore, the range of maximum lies between 2 minima, and that for minima lies between 2 maxima. So here this maximum point is actually lying between these 2 minima, whereas this minimum point is lying between these 2 maxima. Now what about increasing and decreasing? So if y equals to fx, then what about dy dx? Dy dx means f dash x. If the tangent at any point x has a positive slope, then f dash x is greater than 0. That is, tan theta is greater than 0. That means it is having a positive slope. On the other hand, if it is less than 0, so dy dx, that means tan theta is negative. That means the tangent at that point is having a negative slope, that is, it is inclined in the negative slope direction. So in that case it is f dash x less than 0. So it is very simple. F dash x greater than 0 means the movement is in the increasing order, and if it is f dash x is less than 0, so the movement is following the decreasing order. So how would you find the maxima and minima? So here are some rules. Here are the rules. So we have to first of all find out the differentiation of fx with respect to x, that means dy dx or f dash x. Then we have to equate that value with 0 and by solving to find out the value of x. Now put that value of x within fx, okay, and that fx would definitely have either maximum or its minimum value. So how would you come to know that the value is either maximum or minimum? So in order to do that, we have to again differentiate that f dash x. That means double differentiation of f dash fx would be taking place, and if the double differentiation value is greater than 0, then it is minima, and if it is less than 0, then it is maxima. Okay, so this way we can calculate the maxima and minima. So let's discuss a mathematical problem. If we know the actually trigonometric functions in the previous lecture, so if some function of x is 3 cos square theta minus 1, where 0 less than equal to theta less than pi, then the value of fx is what? So this is the MCQ type of question. It will be carrying 2 marks. So what should be the correct answer out of this? Theta is 0, then its maximum, or theta is pi by 2, then its maximum, theta is 0, then it is maximum. Theta is pi by 2, it is minimum. So this way there are 4 options. Okay, and let's calculate. So fx equals to 3 cos square theta minus 1, so that theta has a range which is greater than equal to 0 and less than pi. So what is the first derivative? The first derivative, or the first differentiation with respect to theta, is 3 cos square theta minus 1 would give the result 6 cos theta minus 6 cos theta sin theta. Okay, and within the range 0 less than equal to theta less than pi, the first differentiation, if equated with 0, then it gives the result theta is either equal to 0 or equal to pi by 2. Okay, therefore at theta equals to 0 and pi by 2, the fx would have either the maximum value or the minimum value. Okay, so what is the double differentiation? So we have to doubly differentiate the result of f dash x. That means we have to differentiate f dash x with respect to theta. That means minus 6 cos theta sin theta, and the result is minus cos theta of d theta of sin theta plus sin theta into d theta of cos theta, and it is equal to minus 6 into cos x cos theta into cos theta plus sin theta into minus sin theta. Okay, and it would give the result minus 6 into cos square theta minus sin square theta. Now at theta equals to 0, f double dash x equals to minus 6 cos squared 0 minus sin squared 0. That means minus 6, which is a negative value. That means it is maximum at theta equals to 0. And at theta equals to pi by 2, that means 90 degree, we find that f double dash x is positive. So it is the minimum at pi by 2. So the correct option is option B. Okay, fx is maximum at theta equals to 0 and minimum at theta equals to pi by 2. So this is a 2 marks MCQ question. Now in another question, which is numerical answer type question having 2 marks, you'll be asked a function of x equals to 3 cos square theta minus 1, where theta less than equal to 0 less than pi, then the maximum value of fx is what? Okay, so the same question, but you have to say the maximum value. Okay, so the solution is same. Okay, the fx is given, then f dash x, we have already done it, and equating f dash x with 0, we get theta equals to 0 or pi by 2. These all things have been done in the previous question. Okay, because theta has the range 0 less than equal to theta has the range which is greater than equal to 0 and less than pi. Now we get back to the expression of fx and find out its corresponding values when theta equals to 0 and pi by 2. When theta equals to 0, then fx equal to 3 cos square 0 minus 1, that is, it is plus 2. Okay, and when theta equals to pi by 2, then fx equal to 3 cos square pi by 2 minus 1, that means which is equal to minus 1. So which is the maximum value? 2 is the maximum value. So your entry in the computer screen should be 2. Okay, because this is numerical aptitude, a numerical answer type question. So you have to just type 2 and press enter button. Now move on to another subtopic, which is integrals. Integrals are of generally 2 types. One is definite integral, another is indefinite integrals. We have to start from indefinite integrals, where the results would be involved with some integration constant. Here c would be the integration constant. Okay, so first of all, d dx of fx dx equals to fx plus c. Then summation of 2 functions with dx would be integration of 2 functions. Next, if a is some constant, then integration of a dx would be a into x plus c. And if n is some positive integer or whatever, it is an integral number. then the value would be x to the power n plus 1 divided by n plus 1 plus integration constant. If it is dx by x, then its integration would result natural log of x plus integration constant. If it is exponential x dx, then the result is exponential x plus integration constant. If it is natural log of x dx, then integration would give the Stirling approximation type of result, x ln x minus x. This result would be utilized during the Stirling approximation, and then finally here an integration constant there. And if it is integration of dx divided by x into a plus bx, where both a and b are constants, then the result is minus 1 by a natural log of a plus bx by x plus integration constant. Next, integration of sin x dx is minus cos x, whereas integration of cos x dx is sin x. Integration of tan x dx is natural log of sec x plus integration constant. Integration of cot x dx is natural log of sin x plus integration constant. Integration of sec x dx is nothing but natural log of sec x plus tan x plus integration constant. Integration of cosec x dx equals to natural log of cosec x minus cot x plus integration constant. Integration of sin squared ax dx equals to x by 2 minus sin twice ax over 4a plus integration constant. Integration of cos square ax dx equals to x by 2 plus sin twice ax by 4 plus integration constant. Integration of sec square x dx equals to tan x plus c integration constant c. Integration of cosec square x dx equal to minus cot x plus integration constant c. Now the value of integration of exponential ax sin bx into dx, where a and b are constants, then you will get a huge ratio where in the numerator you have to put e to the power ax into a sin bx minus b cos bx, and in the denominator you would have a squared plus b squared, and then finally plus some integration constant c. And then integration of a to the power ax into cos bx, where a and b are constants, then in that case the same ratio, just the plus sign becomes minus and the sine and cos interchange their positions. So it is exponential ax whole to into a cos bx plus b sin bx, and in the denominator the value is same, a square plus b square, and then finally it would be added with some integration constant. And then if it is 1 by root over a square minus x square, where a is a constant, in that case the integration with dx would be sin inverse x by a, and then plus integration constant c. And if instead of minus, if it is plus, then the result is tan inverse x by a, and then plus integration constant. And in case of hyperbolic functions, integration sin hyperbolic x dx is cos hyperbolic x plus c, but the cos hyperbolic x dx must not be minus sin hyperbolic x plus c, it is here plus. Okay, so integration of cos hyperbolic x dx is equal to sin hyperbolic x plus c. Okay, now move on to definite integrals. These definite integrals are actually utilized very much in case of calculations of kinetic theory of gas, different probabilities of velocity distribution, energy distribution, etc. So if it is these definite integrals would not have any integration constant, and they must have some limits, lower limit and upper limit. So integration 0 to infinity x to the power n e to the power minus ax dx equals to n factorial divided by a to the power n plus 1. Integration of e to the power minus x square dx from the limit 0 to infinity has the result half into pi by a whole to the power half. For integration 0 to infinity x into e to the power minus ax square dx equals to 1 by twice a, while integration 0 to infinity x squared e to the power minus x square dx is 1 by 4 into pi by a cube whole to the power half. Integration 0 to infinity x to the power twice n plus 1 e to the power minus x square dx equals to n factorial divided by twice a to the power n plus 1. Integration 0 to infinity x to the power twice n e to the power minus x square dx is actually equal to the series of odd numbers up to twice n minus 1 divided by 2 to the power n plus 1 into a to the power n into pi by a whole to the power half. If it is integration of 0 to m, not infinity, keep it in your mind, 0 to m, then x to the power n of e to the power minus ax dx is actually It's a very complicated number, which is n factorial divided by a to the power n plus 1 minus exponential minus am, then sum over I equals to 0 to n, okay, where it is the summation of n factorial n to the power there is minus I. So this I may have the value 0 to n. So it is a series, summation of a series, okay. Then a to the power I minus 1 into n minus I factorial. Next, integration 0 to a. Here the limit, maximum upper limit is a. In that case, some function fx along with dx would give the result integration 0 to a function of mx minus a with dx. Okay. Now, if fx is odd, then integration minus a to plus a fx dx is 0, and if fx is even, then integration minus a to plus a fx dx is twice integration of 0 to a fx dx. Okay. Now move on to some numerical problems. So question number 3, the correct expression of the integral in order to calculate the area of a rectangle. So how to calculate the area of a rectangle? If length is a and breadth is b. Okay, so these are the 4 options. Look here, in these 2 options, integration 0 to a is common, dx is also common, but integration of a or b. So you are moving along, actually along a. Okay, so the limit should be 0 to a. So that means you are moving along a. Then if you are moving along a, then the value of dx is actually indicating the length. Okay, so you are moving along the length. Then length must be multiplied with the breadth b. So here it is the correct option. Breadth into length, small length is dx. Then what is the range of small length? Its lower limit is 0, upper limit is a, because the length is changing from 0 to a. Okay, so moving from 0 to a, but the width is b. So b is constant, but dx is variable, which is 0 to a. So this is the correct option. And see, this is a multiple select question of 2 marks, so you may have more than one correct options. So this is a wrong expression, but here look, dx, and here dx dy. Okay, so multiplication of 2dx or multiplication of dx and dy, which one is correct? Actually this one would be correct, because you are integrating dx from 0 to a and you are integrating dy from 0 to b. So if you are moving along the length, then the limit should be 0 to a, and if you are moving along the breadth, then the limit should be 0 to b. Okay, along the length, in both cases the limit cannot be 0 to b. So option D is also the correct option. Okay, so A and D are the correct options. So for this is multiple select question. Next, the correct expression of the integrals in order to calculate the volume of sphere of radius r is what? The radius is r and spherical coordinates like theta and phi. Okay, so the volume of sphere, this is MCQ, it is having only 1 mark. The correct option is option B. In option B, theta has the maximum value twice pi. Phi has the maximum value twice pi, whereas theta has the maximum value pi. So this option is the correct option. All the things are same. 0 to r, r squared dr. In all the 4 options, the same thing. Here, sine theta d theta is also common, but the lower limit is also common, but the upper limits in 2 cases twice pi and in 2 cases only pi. So these 2 would have been correct, but out of these 2 only this one is acceptable. So option B is the correct option. Next, the value of the integral. It came in 2005 IIT-JAM, e to the minus x dx square, x square dx. So we have just worked out this one. And how to do this? All the options has the value. Look, x square e to the minus x plus twice x into e to the power minus x plus twice e to the power minus x. All the options, these things within the bracket are common. Here it is actually minus 1. If you take minus 1 as common, then the same option. Okay, here minus, here plus half outside the bracket, here 1 is outside the bracket. So they have different coefficients. Here in option A plus 1, here in option B minus half, here in option C plus half, and here in option D minus 1. Okay, so just do a back calculation. This is the better option. So do the differentiation of this term, and if you differentiate this one with respect to x, then the result is this one. Okay, this is the first line actually, differentiation. You know how to do this, and finally we get the result minus 1 into e to the power minus x into x squared. Okay, that means the coefficient should be minus 1, the correct coefficient. So answer D would be the correct answer, because here the coefficient is minus 1. So this way also, by doing the back calculation, you can work out these types of problems. Now move on to our final topic of today's lecture, ordinary differential equations. Okay, so an ordinary differential equation is a differential equation containing one or more functions of one independent variable and the derivatives of those functions. Some examples of ordinary differential equations are these are dy dx equals to e to the power x, dy dx whole square equals to ax square plus bx plus c. Okay, d2y dx square equals to 0, d3y dx cube whole square equals to x square dy dx. Then d2y dx square plus 5 into dy dx whole square plus twice y equals to 0, d3y dx cube whole square equals to x into dy dx whole cube. These are the examples. Then triple differentiation of y, this one's whole square, then x square into whole cube of double differentiation of y minus twice x plus 11 equals to 0. So these are ordinary differential equations. And now how to find out the order and degree of a differential equation. Okay, so the order of a differential equation is the highest derivative in the differential equation, and the degree of a differential equation is the power of the highest derivative in the differential equation. So we have to first of all select the highest power of the differential equation. Okay, highest derivative, and then the highest power of that highest derivative. Okay, now let's discuss with some examples. Let's elaborate here. So it is a single power, it's one power, so no problem, and its power, overall power is also 1. That means its derivative is 1, highest derivative is 1, and its power is also 1, so it's order 1, degree 1. Here the highest derivative is 1, okay, but the corresponding power of that highest derivative is 2, so order is 1 but degree is 2. Now here it is a second order differential equation because it is d2y, so the highest differentiation is 2. Okay, but what is its power? Its power is 1, so its order is 2, degree is 1. Here d3y, so order is 3, and here due to this degree is 2. Here the highest derivative is this one, d2, so order is 2, and what about its power? It is 1, so degree equals to 1. What about this problem, this one? The highest differentiation is 3 and the corresponding power is 2, so degree order 3, degree 2. Here highest differentiation here 1, 2, 3, so 3 is the order, and what about its highest degree? It is 2. Okay, corresponding degree is 2. Then this one is the highest derivative, d4y dx to the power 4, and its degree is 2, so order 4, degree 2. Now move on to another question, IIT-JAM 2009 question. So which of the following is not a solution of the equation this one equals to 0? Okay, these types of equations we have to deal in quantum mechanics, so let's solve this question. So all the solutions except this option, x equal to a t square, satisfies the given differential equation. Okay, this equation, just put the value of x, a cos omega t, okay, a sin omega t, or this one, then it will be satisfied. But for this one the equation is not satisfied, so this is not the solution of the equations. So since the question is also, you have to find which is not the solution of the equation. So this one is the correct answer. This is not the solution of the equation. Okay. And last and final question of this lecture, the function y equal to e exponential minus x squared, that means x into e to the power minus x squared, has the maximum at x equals to minus 1 by root 2. So it has a maximum value if you put x equals to minus 1 by root 2. So the second derivative of the function at the minimum is, sorry, this is not maximum, this is minimum. And at that point, the second derivative, what should be the value? So we have just differentiated this. Okay, it came in IIT-JAM in 2013, and the solution is, so just put the value of y as y equals to x into e to the power minus x squared, isn't it? Then single differentiation. Single differentiation is e to the power minus x squared into 1 minus twice x squared. And double differentiation is this one. Okay, just differentiation of this one. So the value is this one. And then put the value of x equals to minus 1 by root 2, this one, minus 1 by root 2. Then what should be the value of this one? Value of this one is 2 root 2 e to the power minus half. So the correct option, which one? This one. This one is the correct option. So option A is the correct option. Okay, so that's all for today. Thank you. And our next topic is in tutorial number 4. There are lots of topics. So this is the last lecture on basic mathematical concept, vectors, matrices, determinants, and elementary statistics and probability theory. And after that, this basic mathematical concept, this chapter will be finished. Then afterwards, we shall start atomic structure. Okay, so that's all. Thank you. Have a nice day.